Hello everyone, it's September 7th. Well, the main thing today was wrestling to deploy fast API onto Lambda. It was an interesting exercise. Tried, you follow online a tutorial, but that was from a couple years ago. It didn't quite work, and then decided to go with Docker. Man, Docker is so good. It's a godsend. But it still took me a long time to figure everything out. But yeah, that's that. But the most impressive thing I did today was watching the video about bed bugs. Yeah, who's that guy again? I forgot the name. That guy, Mark Roble. Yeah, him, and he's. I think that was his latest video about bed bugs. And I looked up that product that he talked about that had very effective killing rate, diatomaceous earth. And yep, I like the saying that there's, you develop any kind of chemicals, they will develop a resistance to it. The insects can develop resistance. But this stuff, this diatomaceous earth, the killing mechanism is to dry you out. And if you want to be immune to that, that means you have to be immune to dehydration, which is impossible on this earth, on this lifespan. I don't think any creature can live without water. It's so deeply intertwined. There's basically no pathway that you can bypass that. It's too fundamental, right? If you use any toxin, any chemicals, you're trying to block one pathway, but biology always find another way. And all of these are not fundamental. They're good ways to kill or to whatever it does, but biology finds an alternative. Evolution finds an alternative, except when the killing was due to dehydration. And this thing is so easy to do. I mean, it is messy. I was reading reviews on Amazon about diatomaceous earth, and everybody says it's just incredible. It works, but it's just so messy. The thing is just a fine powder and it sticks to everything, which it should, right? If you want to use it as a mean to kill insects you don't want. You want it to be very difficult to remove. You want it to be fine powder so it can stuck, right? It's stuck to the animals, stuck to the not animals, stuck to the insects. Cut open their exoskeleton and then just try them out. That's what you want. And yeah, and then apparently it works. So I guess I'm just a little bit less worried now that I know and it's dirt cheap. I mean, I just checked, £4 for $17. It's okay. Even if it's sold for $170, I think for the amount of effect it can have on your quality of life, it's totally worth it. Yeah. I used to live in a trailer home which was infested by fleas. Yeah, it was a long time ago and couldn't believe it. Never got a flea bite when I came from, which was supposed to be a third world country. But now coming here, supposed to be a first world country, and I got flea infestation. I got flea bites. Yeah, quite funny to think about it this way. But anyway, that was pretty bad. And then I think we hired a bug, like exterminator company to deal with it. But now thinking back, I could have just spread this diatomaceous earth, and I could resolve everything. Anyway, let's do today's stuff. Okay, old problem. I don't think we need any more thing. We just go ahead and do it. Yeah, I'll probably just do it right here. Wait, hold a second. Given the head of a link and the two integers left and right, the number of nodes in the list is n, where left is smaller than right. Reverse the nodes of the list from position left to position right, and then return the reverse. Oh, it's a little bit more complicated. Well. Yeah, I think we need to do this way. I thought it was just reverse the linked list. Apparently it's not. It's okay. It doesn't really matter. Okay. We have a left, we have a right. So in the count, right? We're in a count. So basically we need to have a pointer here, and then start from here. We're gonna do the reverse, right? Huh. That's pre. And then if you reverse, you just this point into this. This point into this. And then you need this point into this. And this point into this, right? So we have a dummy, right? And then we start from, that's the pre. That's a node. And then I will start 0, 1, 2. I think it's 1 base. Yeah, it's a 1 base to 1, 2. Then a dummy will be 0, right? And then we move forward to 1. So we move towards the left minus 1. Okay? So we stop. And then we'll have to reverse. Right? Well, basically we start from here, we're going to start reverse. So we say current is here, pre is here, and then, well, this point into here. And once we're done, we move here, done, and move here, done. And then we need to count, right? That's like 1. Oh, we keep going. That's a 1. That's 1, 2, right? 3, and then 4. And then when 5, we get out. Then we get this one. So we get this one. Okay. So we need a dummy. Let's get a dummy. Doesn't matter what the value is. Oh, it does. We can say head. Okay. So we're gonna say list. Start. List node start. Dummy. And we're gonna go for int I equal to 0, I smaller than left, I plus plus. Start equals start dot next. So now start is, we have to keep that. And then we can say list node pre equal to start. List node current equal to start dot next, right? Then we need to reverse for int I equal to left, I smaller equal to right, I plus plus, right? So basically we're gonna do 1, 2, 3, 4. So what do? We're gonna need a list node temp equal to current.next. What if we don't have a next? Yeah, what if we go to the end? Pre is a start. Current, I think, will still be fine. Like this, right? Well, pre will be here. In this case, pre will be this, current will be this. And I'll have current on next. I guess it's fine. What if we don't change the last one? Pre is here, current is here. Yeah, I think it's fine. Because current will not go beyond the last one. Current will not go beyond the last one. So we always have a current on next. So that's the temp. Then that's the pre. It's the current. Then we simply say current.next equal to pre. Current.next equal to pre. And then pre equal to current, current equal to temp. Current.next equal to pre. Pre equal to current, pre is here. Current equal to temp. Next round, temp is here. Then current.next equal to pre. Yeah, and all the way, and then current equal to here. And then we do it again. Current equal to here. Pre is gonna be here, and everything pointing this way. And then we need to move things around a little bit last time, which is start.next. Need to set to pre, because at the end pre is here, current is here, right? And then, ooh, how about this thing? That's start on next. I should say start on next. Next shall equal to current, and then start on next. We go to pre. Then we return dummy.next. All right. Give it a shot. Oh yeah, I thought I would not having this problem. Interesting. Is the first or the second one? It's probably the second one. Oh, we're not even right in the first one. The hell? Alright, we start as I is 0. Okay? And then start equal to start.next. Start equal to here. And then I become 1. Oh, well, that's not right. This is not right. Then we have to do left -1. Oh, we can start with 1. Start with 1 because start equals start. That's here, right? Start is here. and then I plus plus become 2, and then we get out. That's the start. This one right? Okay, so this one's all right. Oh. Yep, I think this might be right. I think I have one more test case. Let's just run one more test case. 1, 2, 5. That's correct. We're good to go. Yeah, I think this is good to go. Yep. So what would you say? 92. That's straightforward. Find the use a dummy value, use a dummy node at the start. Find the node before the first of the reverse range stretch, reverse stretch. Perform the reversal and then reconnect. It's basically how it is. One pass. Okay, that's it. Oh, tired. Nothing more. I'll just keep going. Yeah, we can take a look. Oh, this is the yesterday's. I said I need to take a look at the solution. All right, let's take a look. It was trying to get cache, and my way of doing it is definitely not the best. All past inputs and the associated function outputs. Linear search on all previous inputs will take a long time, eventually to the point where the optimization actually slows down. Is a dictionary that maps inputs to outputs. However, it isn't obvious how to convert an array of arbitrary inputs into something that a map could access as a key. Two empty objects may serialize the same string, but in fact we're not. Yes, that's the problem, right? So we have the first approach, a trie. Wow. I did not consider a trie. Huh. Yeah. A trie could work. And you can use a trie. Convert an array of inputs into a string. How do you handle undefined? Create key generator. Numbers. And we have a cache. Wait a second. Wait a second. Count. What the hell is this count? A key generator. And we'll turn each turn each argument into a number. And a key generator has a map in it, which means has input, I'll return it. If it doesn't have input, I'll get a count. It's the same key generator. So everybody, all the return functions sharing the same count and the same map. So each time a new argument comes, it will give you a different value. Because you will not have the same input. You're using map. Oh, I mean any value. Oh, wow. Map is powerful. Oh. Map is very powerful. So that's why you can just check. You know what? I'm gonna check. So you're telling me okay. Then we can say foo.set this one. So foo dot has. Oh, so it's doing equal. Holy crap. Yeah, so every time it's each new thing get a new count. Wow, that's actually quite smart. That is quite smart. Memory deallocation weak maps. I want to read this tomorrow. I think we can try, let's say, implement a trie solution, and we'll do the other one tomorrow. Yeah, let's try the trie solution. All right. What we need, I mean, each trie basically is just a dictionary, right? Each trie is a dictionary. So what I can do, I can do a trie node, or you can do you basically want to return a function in which when you call it, and that's okay. So all we need to do is to have a trie but we need a map, right? There has to be a map. Each one has to be a map. Okay. So are you telling me that if we say foo equal to new map, foo.set, and I do a set again, oh my, yeah, it's two different things. Ooh. Oh, holy crap. Okay, so I can say const root is equal to a new map, right? And then when we get a function, we will we'll get a trie out of it, right? We'll get a trie out of it and to see if we can have the result, right? The res, yeah, you can call it res. Oh, what if your argument passing in is a res star? What if the argument passing in is star? Jesus. None. Not equal to none. So I can use none. Can I use none? Is none a thing? Inputs is not a none. Wait, are the inputs always just integers? Hold on, none. Can I do... Oh my god, you can. Oh, none it is. We're gonna do none. Okay, okie dokie. So we'll have to go through, and then if it doesn't exist, right? So we're gonna say let node equal to root, and then for const a as argument of args, right? We say if node.has a, if node.has a, then node equals node.get a. And we have to go through the whole thing. Else, if node does not has a, then node.set a new map. I think I shall do if it's not, right? Okay, then once we are done, we need to see if basically we are traversing and we're setting a new thing. And we just say if node.has none, return node.get none. We can say use none as the indicator of the end of a series of args. Otherwise, node.set none function args and then return put it here. This is gonna work. Yeah. Map is a very powerful. It's much more powerful than a regular object. Map can use anything as its key, including objects, whereas an object can only use string or symbol as its keys. E.g. foo equals a new map. Foo.set 1 get undefined. Okay, give this a shot. Nice. Very, very nice. This is very, very nice. Almost as nice as you can get. I don't even want to try the other one. This is the one. The try is the solution. Alright. Yeah. Try is the solution. Okay, I just keep reading. A professional implementation, right? Imagine an object was passed to the memorized. It could be almost any non-primitive External code stopped referencing this object. Ideally, you will want to be freed up and also removed from cache. However, the above implementation would only help to remove, never get deallocated. When a key is deallocated, the map will stop holding the key and it will start referencing the associated value. Wow. What is this? Memorize. Oh. Oh. I think. Oh. Least recently used, right? So you can remove some. Time until expiration, most recently used, least frequently used. Wait, hold on. Nan is not equal to nan? But if you if you put nan as this, is it true? That's JavaScript. Impure. Yeah. The reference of not its content. Yeah, that's why if you pass in the two empty objects, they are considered to be different. Understood. Okay, so yeah, I consider this problem done. Good problem. Group by. You wanna do it today? Yeah, I do have an interview coming up, so maybe I should. Let's just take a look. It's medium, so probably it's not that hard. Enhances all arrays such that you can call array.group by method on any array and it will return a grouped version. A grouped array is an object where each key is the output of and each value is an array containing all items in the original array with that key. The provided callback will accept an item in the array and return a string key. The order of each value list should be ordered the item appear in the array. Yeah, of course. Okay. Basically just to implement low dash. Low dash array is this function item.id. Interesting. Okay, let's implement this. So I don't have a straightforward idea, but I think as I start to write it, the idea shall come. I mean, basically, right? Basically, we can access this, right? We shall do a const res is equal to an object, and then maybe we can map. Map will actually be harder to do. I think for will be easier to do. You can say element of this, right? And then res key, const key shall equal to function called this. No, element. Right. So if not key in res key shall equal to this, and then res key dot push element, then we return res. That looks good. Pretty straightforward. I wondered if you can use a fancier method to do this. Array reduce. Oh, okay. Reduce. Yeah. How do you use reduce? JavaScript. Reduce. How do you use reduce? Array initial value. It provides initial value. But you have to do, you cannot push, right? You have to concatenate. Or, I have an idea. How about right, and then we say this dot reduce accumulate current what do we say? The accumulate Oh, we might be able to return this directly. Accumulate. Now we can just do this. Const key equal to current, right? If not key in rest in accumulate key equal to this, and then we say accumulate key dot push current return accumulate, and we'll start with this. All right, does this one work? This one work? It does too. It does. Do you have any other method? Reduce. Reduce. All right. I guess that's that. It's pretty straightforward. That'll be it. I need to go take a break. It was a long day today, and tomorrow's gonna be long as well. All right, I'll see you guys tomorrow. Adios.